My name is Roy Bell-Chamber, so I work in the product management team at NetGuardians, and I'm delighted to have with me today Stefan Singh from Pictet Group and Jerome Curley, Chief Technology Officer from NetGuardians. If I could ask each of you in turn just to give a couple of minutes on yourselves, talk a little bit about your background, introduce yourself, and explain where you got to, how you got to this point in time in your professional careers. Perhaps if I can ask Stefan firstly.
Yes, please. Thank you. Hi, everyone. Can you hear me?
Yes.
Yeah, perfect. So I'm Stefan Singh. I'm the Chief Data Officer for Risk and Compliance functions at Pictet Group. I have a team working on the entire data value chain, from quality and governance, data engineering, and even analytics. I'm actually engineer, graduated from EPFL in communication system. And after graduating, I was a consultant for 2 years before joining Pictet. It was 13 years ago now. And at Pictet, I had several roles. I worked at IT, also in transversal project management and strategic planning. And after that, work on the data space.
Excellent. Thank you. Jerome, may I ask the same of you, please?
Yes, please. Thank you, Roy. So my name is Jerome Curley. I'm Chief Technology Officer at NetGuardians. Joined the company 7 years ago. My job at NetGuardians is to define our technology, where the technology is both, the platform on which we run the analytics and the analytics itself. I'm in the wonderful business of software engineering and computer science for nearly 20 years. Looking forward next year when I'll be finally able to say more than 20 years, gives legitimacy on the topic. Made most of my career in financial institutions or fintechs and companies working for financial institutions, and it's obviously a big passion as well.
Thank you very much to both of you. Before we dive in, maybe just set the scene a little bit here before we dive in specifically to talk about AI applied in fraud prevention. Perhaps talk a little bit about, AI. So it's everywhere. I mean, and that's obvious. So it touches our lives every second of every day, practically, in ways that we both see and don't see. Driven, obviously, by advances in techniques and technologies. Made possible, I guess, by the explosion in data to feed those AIs. And that data obviously has ballooned massively in the last decade or so, but ultimately supported and made possible by the enormous growth in both the infrastructure on which to run those AI, but also in the compute power. So not just sort of, ubiquitous elastic compute in the cloud, but also right at the other extreme, we all walk around with phones in our pockets. Those phones now typically come with their own AI chips in them. And those phones have compute power that kind of would have shamed a desktop PC, 5 years ago, and probably would have shamed a supercomputer 20 years ago. So before we kind of drill down into that, keeping it still at the high level, Stefan and Jerome, can we talk a little bit about AI in a general sense, just to kind of lead into it? So perhaps the first question could be to Stefan. If you could briefly explain a little bit about what Pictet Bank's approach is to AI.
Yes, of course. I will answer for Pictet Banks and not talk about Pictet Asset Management because they have their own approach and it's out of my duties. But regarding the banks, maybe you are aware or not that innovation, including AI, is one of the 7 ambitions of Pictet for 2025. So in this respect, we are totally AI enthusiastic. However, we are facing challenges such as data quality challenge, such as infrastructure architecture challenge, and we have in addition strict rules in data privacy. So currently we do an opportunistic approach to AI and machine learning, and it's mainly driven by risk and compliance.
Okay. And what sort of applications have you used machine learning and AI for in the bank?
As I said, it's currently, yes, risk and compliance. So okay. Anti-fraud, of course, and now it's for 2.5 years. We have this application. We have also application in anti-money laundering, such as client risk scoring for AML purpose. And one other application is control selection, is to prepare sets of data for controllers.
Okay. And what do you mean by that specifically?
For example, if you have tons of transaction or tons of visit minutes, you have to control is the fact to create a good quality sample for controllers.
Okay, understood. And then maybe pass it to Jerome. So, thinking of that AI journey in a general sense still, where do you think we are?
I'm glad you asked this question, Roy. And before answering that, I would want to make a distinction between, science fiction and reality. And that would be making a distinction between what we call strong AI and weak AI. So strong AI would be an application where we develop an algorithm or computer system able to contextualize, for instance, or exceed its programmation scope, or show sensitivity. All these things we have seen in science fiction movie. And the good things, or perhaps the bad things, is that this is really just only science fiction. Weak AI would be computer system where, an algorithm gives a solution to a mathematical or analytical problem, such as a classification problem, or optimizes a mathematical function, or recognizes patterns. And in the field of weak AI, the progresses are tremendous and very fast. And I really believe that we are just at the beginning of the journey. We are just starting. Imagine today we're seeing applications for several years, such as robo-advisor, nearly autonomous cars, financial investing advisors, smart assistants, and so on. Tomorrow, we will see reliable and entirely autonomous driving cars. We will see autonomous planes, autonomous trains. We will see buses. Our children will think it's as crazy to think that one day a human being will have driven a car, just as we think it's crazy that we have been taking horses to go to school one day. We will see automated and reliable medical diagnosis, automated response and countermeasures to cyber attacks, and so on. From my perspective, what is changing today is both the maturity and efficiency of individual machine learning approach and the complexity of AI solutions, where an increasing number of these machine learning algorithms are deployed together towards a superior objective and ultimate objective, for instance, driving a car entirely autonomously. So yes, we're really actually just at the beginning of the journey, and I believe that by 2050 we will be very surprised by how AI applications have become, simply a part of everyday life.
Yeah, interesting. And Stefan, so talking still general sense, what makes a problem one that's suitable or best tackled using AI?
Now, it would be less sexy, as Jérôme explained, but in our applications, a good example is controlling, and it's currently one of my priority. When you have to make checks on huge tons of transaction on visit minutes, for instance, is the way to decrease the workload of people reviewing those, doing those control. So it's to decrease, but with intelligence, the quantity of work and increase the quality of the sample. So increase the strength of the control.
Okay, yeah, that makes sense. And obviously it's all, all centered around the data, that massive volume of data. This is where AI excel, in basically managing that data and using that data to come to decisions. So it's obviously just a question about, the more data, the better, isn't it? Any thoughts on that?
In fact, yeah, my point of view will not be on the quantity of data, but much more on the quality of data. Even if it sounds like a total obvious statement, and as I like to say, everybody at the coffee machine would say data quality is key. It's very important to have good data quality, and that's the truth. But in fact, as soon as you have to pay for data quality, or as soon as you have to do data quality, everybody disappears. So everybody wants to have good data, but nobody wants to pay it or do it.
And so how do you manage that? How do you resolve those challenges?
Actually, my strategy is to use mandatory drivers such as risk, compliance, regulatory to fund data quality projects.
Okay.
So we have to first stop the bleeding by setting a governance and processes and cleans the data. And for instance, we had a few years ago, for regulatory reason, we had to identify all the clients domiciled in a specific region of a specific country. And this information we didn't have in our system. With this driver, this regulatory driver, we could increase the quality of the data, and not only for the country in question, but for the whole total of clientele.
Interesting. So moving from data keeping in similar areas, so let's talk a little bit about the infrastructure side of it. So kind of, you know, if you look back the last decade or so, what you see is, you know, as well as that explosion in the use of AI, you also see massive increase in adoption of big data stacks in terms of kind of the compute infrastructure. Maybe to Jerome to start with, are the two interlinked? Are they joined at the hip?
Yeah, I really think so indeed. I think big data technologies are an enabler to AI application, because if you think of it, the whole hype around big data is just as much about the ability to crush, you know, various and voluminous data in no time, but it's also a lot about being able to gather business insights from this data. Big data technologies are one thing, of course, and their applications are exceeding, obviously, the scope of purely AI application. And we have many applications nowadays for NoSQL/big data technologies. But aside of the technology thing, big data is about being able to extract business decisions from very various, voluminous, and data in high velocity. And this is where machine learning kicks in. And the way I see it, the evolutions in machine learning and AI and big data technologies are really linked and tied to each other.
Okay, interesting. And Stefan, I guess, you know, in terms of architecture, what have you seen? Have you seen any changes in recent years in terms of approaches to this problem?
Yes. For years at Pictet, we are worked by silos. You know, every department used to have its own kingdom, its own little architecture or infrastructure. So we've tried a few years ago to totally inverse the architecture management and to be much more centralized. It was not a success because we have lots of different expertise and lots of different businesses, and all of them needs to have lots of agility. So for us, the truth is in between. So currently, we have a piece of central architecture and piece of dedicated infrastructures.
Okay. And Jerome, you know, do you see evidence of similar elsewhere? Any thoughts on it? You know, perhaps talk a little bit about the foundational layer and the importance of it.
Yeah, and this is a very interesting point. You know, there's this measure obsession myth, which is wrongly attributed to William Edwards Deming, which is one can't manage what one can't measure. And then this other thing that William Edwards Deming really said, which is, in God we trust, all others must bring data. In order to be able to take decisions, we need data. And artificial intelligence is just the same. But just the same, and even worse, artificial intelligence needs even much more data than what we might need to take a decision. And happily, since 20 years or even more than that, banks have massively deployed decision support system, analytical system, business intelligence. So that's a good thing, because we have data today and banks are collecting data. But this decision support system, most of the time, nearly always follow the data warehouse architecture pattern, where data is, you know, from the operational system, pushed, transformed, cleaned, cleansed, polished, enriched, down to specialized data marts, where they are used for specific use cases. And for a long time, that was fine. But at the pace in which systems are evolving today, at the pace at which we come up with new use cases for artificial intelligence, this is not okay anymore. We need much more agility and the need to be ready for unexpected use cases all the time. And the web giants have understood that from day one. The web giants have followed the collect everything pattern. Every single piece of data, every single log, every single trail of activity on their system is collected, because they don't want to end up in a situation where they figure, oh, it would be nice if we could come up with this use case for which we need this data, and oh crap, we don't have the data. And the collect everything pattern is at the very root of the data lake architecture patterns. And from my perspective, banks need to evolve from a data warehouse approach towards a data lake approach, collecting everything and letting the analytics use case pull the data they need and transform it in an ad hoc way instead of doing it the other way around and having the data pushed to specialized data marts. And
Yeah.
data lakes form a tremendous opportunity for artificial intelligence because the data is available. And most of the time, the infrastructure that are deployed for data lakes infrastructure are also very well fit to build artificial intelligence. You know, if you think of it, on Hadoop, for instance, it's fairly easy to build data streaming and real-time processing application nowadays. So I will see that there's a tremendous opportunity for banks with the data lake democratizing to embrace technologies that would make it much more easy to embrace AI application.
Yeah. Okay. Yeah, makes sense. And I guess kind of now drilling down a little bit specifically into fraud prevention and the AI use cases there, if we can. I guess it's interesting. Well, from where I sit, it's interesting. So, for many firms, you know, fraud prevention was perhaps the very first use case for AI techniques in the domain of financial crime and compliance. Let's talk a little bit about this. So, you know, how did we get to where we are today? You know, what was the journey? Again, in the same way as we've talked about it from the general sense, specifically now here talking about financial crime, fraud prevention, you know, how did we get to the point where we are today using AI? If I can maybe ask Jerome to comment in first place on that.
Happy to. Let's give a little bit of history and which will lead to what we do today at NetGuardians. In the early 2000s, fraud detection was really mostly relying on some basic checks on the operational system, and obviously relying on internal control and internal audit coming once in a while to do a little bit of sampling to try to find the biggest cases. And yeah, when you try to detect fraud by sampling, there are good chances that a lot of cases pass through the tracks. In the late 2000s, the internet bubble exploded, the subprime crisis happened, bank margins really reduced, and suddenly the fraud problem was deemed unacceptable, and the losses due to fraud were deemed unacceptable. So banks started to massively deploy specific analytics systems to detect fraud cases. And at the time, these systems were all rules engine. And for quite some time, in the late 2000s and the early 2010s, rules engine did a tremendous work in detecting fraud. But today, we have experienced a change of society. Smartphones have appeared 10 years ago, and the massive digitization of goods and services has profoundly transformed the banking customer experience. Today, we're living at a time where most interactions between bank customers and the bank system or the bank services happen online, on highly customized, tailor-made, and broad services. And this leads to a situation where today, most bank users, most individuals uses the mobile banking software in its very own private way, And how do you want to protect the bank activities using rules if everyone uses the bank service in its own private way? You will need to deploy a completely different set of rules for every individual, thus ending up with hundreds of thousands of rules deployed on your system. And this is impossible, obviously. Artificial intelligence is a tremendous solution to this very problem because it transforms the fraud detection problem into an anomaly detection game, which drastically simplifies the game. And today, elaborated fraud detection artificial intelligence, such as what we develop at NetGuardians, uses a combination of a dozen of different algorithms and approach to detect anomalies and distinguish between wrong alerts, transactions that are for sure unusual, and yet there are no frauds and actual fraud cases. And last but not least, and I hope I have the opportunity to develop that further in a while, the artificial intelligence is also a tremendous way to understand the banker feedback and capture the banker expertise into understanding what distinguishes a fraud from a wrong alert.
Okay, good, interesting. So maybe then to Stefan, following on from that, does that mesh with what you see within Pictet Bank? Does it align with how you use AI in your fraud prevention programs? Perhaps you could talk a little bit about that. Maybe you give us an example of, in real world use case, if you can.
Yes, perhaps I can explain what exactly to identify a fraud in simple words is the fact to identify in all your transactions the transactions that are unusual and make controls on those transactions to guarantee what they really are. Are they frauds or not? And for example, let's imagine if you have a Swiss client, just if we focus on one client, you have a Swiss domicile client, and these clients make all its transaction in Swiss francs or euros, and all the transactions are done in Europe, for instance. One unusual transaction would be one transaction in Europe, but in Japanese yen, for instance, or one transaction outside Europe, so to Hong Kong, for instance. So as soon as you detect those unusual transactions, you have to make dedicated controls to ensure they are frauds or not. And they can be easily detected with for instance, a simple algorithm such as linear regression.
Okay.
But this is something I explain more in detail in talk fraud analytics. Maybe you can share the YouTube link for the as resources for the participants. Maybe I have a dedicated talk on that.
Yeah, and we've got I think we've got a slide at the end which will show when we're in the Q&A session. We can show a link and people can grab that if they're interested. Interesting. So, you know, if you think about these AI, you know, they're basically just machines mimicking humans. So you still need the humans. You need the humans there, I guess, to not only program them in the first instance, but also to train them to distinguish the good from the bad, the right results from the incorrect results, and also importantly, I guess, to interpret it. So, you know, it's simply a case, surely, Jerome, of, you know, writing those algorithms and then teaching each of those chosen algorithms how to spot the frauds that they're tuned to. Correct?
Yeah, it's exactly that. And before answering this, I cannot stress enough how much the talk that Stefan did at Fraud Analytics was very interesting indeed. So it's a good thing we're providing the link at the end of this presentation, and I can only encourage the audience to have a look at this talk. It was a fairly good talk, Stefan. Anyways, yeah, with regard to training this algorithm, you know, there's no magic silver bullet when it comes to efficiently detect frauds in banking institutions today. And what we find out at NetGuardians is that our success comes from the combination of a lot of different techniques and approaches and algorithms at the end of the day that we combine together, each of them solving a sub-part of the problem. So I can explain to you what we do at NetGuardians, which we have called 3D AI. This is marketing speech, the marketing word. 3D AI is a combination of three fundamental techniques working together. We do anomaly detection leveraging on unsupervised learning. We do fraud recognition leveraging on supervised learning, and we do adaptive feedback management leveraging on active learning. Unsupervised learning in anomaly detection is a combination of multiple unsupervised approaches, which are aimed at detecting anomalies in the universe of transactions we analyze from different perspectives. And in these anomalies, we have all the frauds, but obviously we have mostly false positives. But this is where the managed learning, this is where the fraud recognition techniques kick in, leveraging on supervised learning. At the end of the day, if you think of it, not so much to recognize fraud, but much more about discarding false positives from the set of anomalies. And then there's adaptive feedback. And adaptive feedback leverages on active learning and a whole bunch of techniques and approach and technologies to ensure the feedback from which the AI learns to be more accurate in detecting fraud is of great quality. And this is absolutely key.
And can you talk a little bit, so you said you wanted to elaborate, can you talk a little bit about why it's so key? And if so, what the techniques are to make sure that you're doing it well?
Yeah, I was fearing you'd ask that. This is very challenging to explain. So let me start by giving you an example. Imagine that my oldest son goes 1 year studying abroad as part of an Erasmus exchange program in Warsaw. So in September, he left for 1 year in Warsaw for his first year, so Master of Science in computer science. So I am sending him in September 20,000 euros for his year studying abroad. From the bank perspective, this is a 20,000 euros transaction, withdrawing money from my account by UBS Switzerland and sending the funds to mBank in Warsaw. So that's the way this transaction looks like, right? Now imagine the second situation. Imagine the case where an attacker compromises my computer with the Gauzy worm and operates my banking sessions through Gauzy from Belarusia, for instance. And one day when I log in my banking session, the attacker gets an alert and he starts operating my banking session instead of me. And he inputs a fraudulent transaction, withdrawing 20,000 euros in September and send them to a mule account that he opened using a wrong identity by mBank in Warsaw. The first example is clearly a legitimate transaction. The second example is clearly a fraud. From the bank perspective, what's the difference between these two cases? None. Absolutely none. It's a 20,000 transaction withdraw from my account by UBS using the banking session on my usual computer and sending the money to a first-time beneficiary in Warsaw. No difference. And that's the whole problem when it comes to detecting fraud. At the end of the day, a good fraud detection solution does not focus so much on fraud. It focuses on blocking and preventing every single transaction that is simply too risky and too unusual for the bank to afford letting the funds go out without a further investigation by someone within the bank. So it's fundamental that the system understands this notion of risky transaction. And so here comes the expert within the bank and the need to get feedback from the expert to learn what makes a transaction high risk. And the way we do that at NetGuardians is that every time a transaction is blocked, our system asks a feedback to the bank expert reviewing the hits, the transaction being blocked. And then obviously, if the banker confirmed it's a fraud, the game is done, the job is done. But in the other case, if the banker says it's not a fraud, we request an additional feedback. We request a classification as high, medium, low of the transaction risk. High would mean that Guardians, we completely understand why you blocked that transaction and it's absolutely sound to do that. Please make sure you block such a case again in the future. Medium would mean, okay, that Guardians, we kind of understand why you blocked that, but honestly, it was fine. And low would mean that Guardians, why the hell did you block that transaction? Please ensure you're not blocking such cases again in the future. So at the end of the day, our algorithms can only be as good as the quality of the feedback they get from the bank experts. Now imagine that we get the feedback from an expert in a tiny bank. It has only one guy reviewing this transaction being blocked, and the guy is doing this job for 20 years. And with the time, he has come to the conclusion that the only thing that matters on a transaction is the amount and if it's a first-time beneficiary or not. And in his mind, a high-risk transaction is only high risk if it's a high amount and a first-time beneficiary. Now imagine that we would blindly apply this feedback when we retrain this model. After 6 months, our models will be looking only at 2 attributes, the amount and the beneficiary, because that's what they would have learned from the bank expert. So it's absolutely key that we monitor and supervise the feedback we get from the expert within the bank to avoid such situation. And we're using different techniques there, leveraging on active learning and other techniques at the end of the day to maximize the entropy we get from the feedback of the bank expert. And this is what we call adaptive feedback, and it's absolutely key.
Okay, good. And so how do we make it easy for those fraud officers in the bank that are being delivered alerts, on those block transactions? How do we help them to understand, to interpret the result that's come out of that AI and ultimately make the right decisions and give good feedback? And we hear loads and loads about, explainability and explainable AI. We've got the European Commission working on it, saying you need to bake it into the designs of your algorithms and your systems. How do you achieve it in practice? It's all very well to talk about it conceptually. Can you give us some specific details? I don't know if you've got anything to say, Stefan, or Jerome first. Maybe Jerome first.
Stefan, let me start. And it's interesting, Roy, because we're seeing that everywhere. You mentioned the European Commission, but it's just the same in Asian countries where increasingly explainability on the AI decision is a key concern. And our solution at NetGuardians to this is fairly interesting and easier than what we could expect. Let me try to explain. At the end of the day, the key to an efficient fraud detection solution is not so much about the machine learning model we use. There are situations where random forest is working tremendously, other situations where XGBoost or other gradient descent, boosted gradient techniques are working better. There are other situations where a simple weighted average model is working tremendously. Again, we don't find the frauds at the scoring model phase. We find the frauds at the feature engineering stage. The difference between a great fraud detection approach and a poor one lies in feature engineering. We have to be very creative into picking the proper direct and indirect features that on the source events that at the end of the day will enable the scoring model to qualify the transaction as being potentially a fraud. And the beauty of that is that most of the features we use are statistical features. So they are kind of interpretable, the features, not the machine learning model and the scores, but the features. Since the features are interpretable, the opportunity we have is to build visual dashboard with fancy data visualization that present these features. And by presenting to the fraud investigator or the regulator a report or a dashboard that shows a statistical analysis on the feature that are the very same that are used in the machine learning model, along with the feature importance chart in the machine learning model, we end up in a situation where 99% of the time we can make 99.9% of the time, we can make the decision of the machine nearly crystal clear. And since we're able to generate this dashboard, we can also export it as a report, attach it to the case that is being sent to the regulator. And by doing that, we address the transparency issue and we address the explainability issue requested by the regulator. And this is interesting if you think of it, because at the end of the day, by doing this job of presenting all this information to the banker, the expert in the bank, so that he can take an enlightened decision, what we are doing is that we are not replacing the human decision process with our analytics. We are enriching the human decision process. And this is called augmented intelligence.
Okay, good. And Stefan, do you see it similarly? If you want to talk about explainable AI and your perspective on it, but also I guess if you want to expand it a little bit, if you want to talk about some, if you see other challenges, if you see other difficulties, other problems that need to be overcome, perhaps you could give us a few thoughts on that.
Yes, maybe it depends on the methodology you use totally. And if you have a descriptive algorithm, even if it's feature descriptive algorithm based on rules, threshold, quantity, currency, for instance, one of the difficulty is you will have tons of hits to be reviewed. So you will not be able to review all the hits. So you will have to sample, and you would miss probably some frauds. If you use a predictive algorithm, it would be based on your knowledge. So the frauds you have been faced by the past. So the little piece of fraud So you will have what we call the unbalanced set of data, because you will have like more than 99% of non-frauds and less than 1% of frauds. So it's totally an unbalanced set of data. In addition, you because it will be based on your knowledge, you would miss a vast array of bucking frauds. So it will not be very very useful.
Yeah, okay. And do you anything to add there, Jerome? Any other challenges? Any other difficulties?
Yeah, thinking out loud, one of the biggest challenges that we're seeing in the field of fraud detection in financial institutions is the way the whole financial system is evolving towards open banking and real-time payment. We can think of SEPA instant payment, for instance, but this is just the beginning. I would highly doubt, the way I see it, my children will again think it's completely crazy that one day we had to wait 24 hours for a payment or for funds to leave the bank when issuing a payment. real-time payment are an emerging new norm, and I highly doubt that there will be anything else than real-time payment in a time frame of 5 to 10 years. And this makes it difficult because the scoring system, the machine learning model can score a transaction in no time. But some of the most important features we use, some of the statistical features we use take a little bit of time to compute. And it's interesting to see that as we are moving forward on the analytics progress in artificial intelligence, we are also moving forward with the technologies aimed at crunching this data, as we said a few minutes ago, in no time. And new technologies today, such as Apache Flink, for a tremendous opportunity to be able to compute all the statistical features that are required to enter the machine learning models in real time, just as we're able to score them in real time. So that's one thing. The other one would be open banking and PSD2. It's interesting to see that as we are moving to real-time payment, we're also moving to a world where the attack surface of financial institution is literally exploding by the need to open APIs to third-party payment providers or other kind of fintechs on the banking information system. And the solution to this problem, and that will be my conclusion on that aspect, is that the key to successfully deploying artificial intelligence and machine learning towards fraud detection and prevention in financial institutions is the ability to build multi-competencies team. We need to have strong financial experts, strong banking experts. We need to have cyber security experts, analytics experts, data engineers, data scientists, and obviously programmers and developers working together as part of our core team to move forward with this kind of use cases that are becoming increasingly, from a technological and analytical perspective, more and more complex.
And so it's kind of building on that theme, I guess, and talking, you mentioned a lot of skills there that you need to kind of combine and have working in unison. I guess the challenge is always going to be, you can do that, you can assemble that team, and you can take a view on the outputs that you're getting from your AI within your own institution. You can even kind of push it further and look at modeling behaviors among groups of peers within your institution. But how do we move it beyond the barriers, beyond the walls of an individual institution? There's lots of talk about consortium modeling, consortium approaches. Stefan, maybe to you in first place, those consortium schemes potentially have huge advantages, but there's also, there's a general lack of confidence or readiness or willingness to adopt them. Have you got any views or perspectives from your bank and your own direct experiences?
Yes, of course. I guess banks would be very fearful to regarding sharing that kind of information. It's very sensitive and confidential information. The fraud we have. Of course, receiving from others all the information it would be very helpful. So maybe one key to give confidence to institutions, to banks, would be to have like a new standard with an audited process and like proven process that it's impossible, it can be reverse engineered. That could be one solution to give confidence, but yeah, I don't know if it's feasible.
Yeah. So how do we engineer those things? How do we engineer auditability into those processes? How do we preserve privacy? How do we make it irreversible so that you can't reverse engineer? Jerome, any techniques?
It's a good question. It's a good question. I don't have a clear answer. It just reminds me of a discussion I had yesterday with one of my data scientists about the blockchain. The blockchain would be a tremendous opportunity. It's designed exactly for that, transparency, auditability, non-repudiation, non-modification, blah, 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 blah. And I'm most definitely not a blockchain expert, so I can't tell you about what kind of applications are being developed in the field of blockchain towards that very objective. But I wouldn't be surprised if we see increasingly, new solutions appearing on one of another of the blockchains, such as Corda, to address that very need. The need to share data relevant data and business insights between banks in a reliable, transparent, blah, blah, blah fashion. And something else that comes to my mind is the distinction we have to make between AML use cases, where the actual customer identification data is absolutely key. If you think, for instance, of transaction screening, KYC, customer screening, and so on, and fraud detection, where actually knowing who's the customer doing this payment is really, completely useless. We don't care. We don't care about whether it's Mr. Curley or Mr. Muller making this payment. We are much more interested to understand where the hell the money goes. Detecting fraud is understanding where the money goes and whether that's legitimate or not. And in order to do that, we don't need actual identification of IBANs or customer account and so on. It's fairly straightforward to work in the fraud detection business with hashes and other representation of the source data, as long as the cardinality and the entropy of the data sets are kept. And playing with anonymized hashes when it comes to identifying beneficiaries, beneficiary bank, and so on, even addresses, even beneficiary addresses, if we find ways to encode them in such a way that the cardinality and the entropy is kept, but yet in an anonymized way, we can very well play with addresses, And if we're able to do that, anonymize this data, then we're able to exchange them between banks. So this drastically simplifies the problem of collective AI, collective intelligence, in the fraud detection business. In AML, it's a completely different story, obviously.
Yeah. Conscious of time here, perhaps we need to kind of move to wrap up. So unfair question time, and maybe you need to get your crystal balls out. So, look, let's say 5 years down the line, where do you see, fraud prevention? Where do you see AI intersecting with fraud prevention? Is it going to be significantly more advanced than where we are today? Stefan, maybe if you can answer from your perspective in first place.
Yes, so maybe I will answer with industry-based and Swiss bank-based hat, but we can see now that people are becoming more and more skilled in IT, programming, and at least more at ease using tools. So what I can imagine is that AI will be very much more accessible to expert or business users. Like the citizen AI, everybody can do a piece of AI like currently everybody can do work on Excel. But the thing is, it will only happen if all the data quality and architecture issues have been solved before, of course.
Yeah. Anything to add to that, Jerome? Different view, similar sorts of view?
Completely similar view. I completely join Stefan on the fact that we will see many more departments, many more people starting to deploy machine learning and artificial intelligence down the line on every kind of businesses where they have IT capacities, completely aligned to that. The last thing I might want to add, coming back to one of the things I introduced I started with in this call, is the distinction between strong AI and weak AI. And in my best guess is that in 40 or 50 years, strong AI will still be science fiction. Skynet is not taking over the world, and Transcendence will remain a good movie, but will never become a reality. Maybe not that sure about that last one. However, the progresses in weak AIs can simply not be foreseen. We're seeing nearly every single day new applications for these machine learning approaches and algorithms. And I can only be very excited to start to imagine what will be the application we will see appearing in the next 20 or 30 years of this technology.
Thank you both. I'm just looking at the clock here, so I think we really do need to wrap up and open it up to some questions. Thank you both for your time. It's been fascinating, at least for me, to listen to you talk and explain the domain and explain some of the challenges. I think we've learnt here, how AI can do a great job in terms of preventing and detecting and preventing banking fraud, in terms of, doing it faster, doing it more effectively, doing it more efficiently if well designed. It's been interesting in terms of, some of the approaches as well as some of the pitfalls that we could possibly need to circumvent on the way. So thank you both for your time today. We have a couple of questions that have come in. Just bear with me. I'm trying to juggle it. This one's actually been specifically pointed to Jerome. Says you've talked a lot in general terms. You've even mentioned some algorithms. How do you know which algorithms work best for which particular problems?
This is a very good question, and unfortunately, there's absolutely no straight answer to this. Again, combination of multiple approach. One of the things we do in the middle of all that is scoring the transaction or the event, computing the risk score, and this is done using different model, random forest, XGBoost, whatever. And it takes a lot of experimentation to find out in which context, which algorithm work better than the other one. For instance, random forest works tremendously good in context where we have a sufficient amount of fraud or high-risk transaction to train it on. And this is absolutely key, a sufficient spread of different situations in the training data set. If one of these two constraints is not respected, then there's no other way than to completely overfit the random forest, and it will be blind to any new type of fraud. So it's not working so good. So we have to find the other algorithm. And what I will say that what is key in our approach is that we have a strong research approach where we try many things, and it's easier for us for a few years since we have a lot of partnership with absolutely key financial institutions such as Pictet, which have enabled us to prototype our approaches on their data. And this is key for us to be able to take decisions and understand what is working best in which context with our approach. So long story short, trying a lot of different things and retaining the ones that work at the end of the day.
Okay, so no magic bullets really. Anything to add to that, Stefan? There's also another question that's come in. So is there a way to attach some attributes to trusted clients to narrow down the fraud protection? I presume that means kind of almost a more trusted client, therefore we're going to not whitelist them, but we're going to perhaps downplay the associated risk. Is there any comments or techniques that you can think or approaches to that? Either of you? Brains ticking.
Stefan, you want to take that one?
The thing we can find, of course, techniques to white or blacklist kind of clients or kind of transactions. It depends totally of the methodology you use, but you can just have like a feature in your data sets and white and blacklist and put a huge weight on this feature on your model. And that would be one option.
Okay.
I joined that.
Sorry, Jerome.
Yes, sir. I completely join that perspective. And interestingly, and Stefan will join me on that. As data scientists, we might not take any preconceived assumption on such a feature. At the end of the day, we want to trust the model. We want to train the model and see if it ends up having a high importance in the classification tree. And if that is the case, then we've been right indeed believing that this feature makes such a high discrepancy between fraud cases or not.
Thank you. So we're over time now. So Stefan earlier mentioned a talk that he gave a while back, and here's a link to the talk on YouTube if you want to go and have a look at it. I would encourage you to. There's some very thought-provoking content there and some very insightful real-world experience, so that's well worth a look at. We will be sending these slides out after the event as well if you want to watch it a little bit later. And then finally, we will also be making available a white paper building kind of on some of the techniques, some of the themes, some of the motifs that we've talked about this morning. So if you want to be high tech and scan this QR code, it should link you straight to this white paper. But as I say, we will also be sending these materials out after the event. And I guess with that, I would like to thank both the participants today. So thank you, Stefan. Thank you, Jerome, for your participation today. It's been very interesting. It's been very insightful having your views and thoughts on these topics. And with that, I'd like to say thank you to the attendees for joining us as well today, and enjoy the rest of your morning or afternoon.
Thank you. Thank you for your time. Thank you, Roy, for animating. Thank you, Stefan, for joining. It's been such a pleasure to do that with you.
Yeah, thank you, both of you. It was a pleasure.
Thanks, Stefan.